Today we will discuss about modulation. This is the original signal. This original signal or audio signal has low frequency and low power. That's why this signal cannot be transported. So it needs high frequency wave. So this high frequency wave is called carrier wave. This wave has higher frequency than this original frequency, and it also has high power than this original signal. Now you have to know what is the modulation. So modulation is a process of placement of this original signal over this high frequency carrier wave is called modulation. So modulation is a process of placement of this original signal over this high frequency carrier wave signal is called modulation. Okay, this is the modulation process. Now there are several types of modulation. So modulation can be continuous wave modulation and pulse wave modulation. Continuous wave modulation is three types: amplitude modulation, frequency modulation and phase modulation. And pulse wave modulation is three types. This is pulse amplitude modulation, this is PAM, and pulse width modulation, PWM, and pulse position modulation, PPM. This is the classification of modulation. Now we will discuss about amplitude modulation. What is the amplitude modulation? This is the box diagram of a amplitude modulation. Okay, amplitude modulation. Here you see this is the carrier wave, this is the carrier wave, and this carrier wave, amplitude of this carrier wave is changing according to the original signal, modulating wave. So here you see that this is the carrier wave and this is the original modulating signal, and the modulated signal will be this. So here you see that this is the carrier wave, and this carrier wave's amplitude is changed according to this modulating signal. This is called amplitude modulation. So what is the amplitude modulation? The amplitude modulation is that the changing of carrier amplitude is in accordance to the amplitude of the modulating signal is called amplitude modulation. Okay, now we will do some mathematical expression to this amplitude modulation. So suppose modulating signal is given by EM t is equals to AM sin omega mt, and carrier signal is given by EC t equals to AC sin omega ct. Now according to amplitude modulation, only the only the amplitude of this carrier modulation carrier wave will be changing. So according to amplitude modulation, the amplitude of the modulated signal will be this. This is A equals to must be A C plus AM sin omega m t. So this is the amplitude of this modulated signal. So what is the modulated signal? Suppose this is the modulated signal. Modulated signal is E. So E is given by A sin omega ct. Okay, what is this? A is AC plus AM sin omega t. So this is AC plus AM sin omega m t into sin omega ct. So this is the mathematical expression for this amplitude modulation. So in amplitude modulation, only the amplitude will vary according to the modulating signal. Okay, and the modulated signal will be A equals to A sin omega ct, and A will be this. Now E must be equals to AC sin omega ct. This can be written as, if you take common AC, then it will be A1 plus AM by AC sin omega mt into sin omega ct. Okay. Now this term is called modulation index. So E is equal to AC into 1 plus MA sin omega mt into sin omega ct. Here AC AM by AC is called modulation index. This is called modulation index. Now it will be, this is AC sin omega ct plus it will be AC into MA into sin omega ct into sin omega mt. Okay, this is the carrier wave. This is the carrier wave. So it will be AC sin omega ct plus, if you take C MA divided by 2 into sin omega ct into sin omega mt. This is the 2 sin A sin B. So it can be written as AC sin omega ct plus AC into MA divided by 2 into cos A minus B minus cos A plus B. Okay, so this is the circular frequency. If you want to express through the frequency, then it will be sin 2 pi fct plus AC MA by 2 cos 2 pi fc minus fm into t minus AC MA divided by 2 into cos 2 pi into Fc plus Fm into T. So this is the equation number. Suppose this is 1, this is 2, suppose this is 3. So this is the amplitude modulating wave. This is the amplitude modulating wave. Here you see there are three terms. This is one terms, this is another terms, and this is another terms. It has three terms. So in this three term, you see this. This is the carrier frequency. This is carrier frequency. This is another frequency, and it has another frequency. So there are three frequency. So if you take this three frequency, this frequency Fc is called carrier frequency. And Fc minus Fm, and there are also Fc plus Fm. This called upper. This is called upper side band frequency, and this is called lower side band frequency. This is two side band. Okay, this is called upper side frequency, side band frequency. This is called lower side band frequency, and this is called carrier frequency. So if I draw the frequency versus amplitude, you see when Fc, the frequency, suppose this is Fc, the amplitude is AC. So this is AC. This is amplitude, then this amplitude will be AC. Okay, and this lower side frequency is given by this is Fc minus Fm, and suppose this is Fc plus Fm. In this case, the amplitude is given by AC into Ma by 2. So this is suppose this is, so it will be like this. So it is AC into Ma divided by 2. This 2 is called sideband frequency, this is called carrier frequency, and this is called lower sideband, this is called upper sideband frequency. Now we have to know what is the now we should know what is the band. What is this band? What is this band width? So band width is given by the f of upper sideband frequency minus lower sideband frequency. So it will be Fc plus Fm minus Fc plus Fm. So this is cancel out. So 2 into Fm. So 2 into the frequency of modulating signal. Okay, so this is the expression. Through this expression we will discuss the amplitude modulation. So this is the mathematical expression. Through this mathematical expression we will explain the letter